Hey guys, it's Miss Emily. I'm going to go through this Unit 1 CDA study guide with you. Each video is going to be a short video about each topic, and remember that the topics are in order of how many questions are on the exam. So the first topic is solving multi-step equations, which means that there's the most questions on the exam about solving multi-step equations. Okay, so I'm going to jump right in. If I'm going too fast, feel free to pause and slow me down. So number 1, we're going to solve for x and describe our steps. So I have 1/2 times x plus 14 minus 6 equals 11. The very first thing that I'm going to do is distribute the 1/2 because I see that I have 1/2 on the outside of parentheses. So 1/2 is going to be distributed to x and also to that 14. So 1/2 times x is 1/2 x, and 1/2 of 14 is 7. So plus 7. Now I'm going to bring down that minus 6 because I haven't done anything with it yet. And I'm also going to bring down the equals 11 because I haven't done anything with it yet. Okay, so now after we distribute, the next step is to combine like terms if we can. And in this case, we can because we have positive 7 and negative 6 on the same side of the equal sign. And so positive 7 minus 6 is going to give us a positive 1. So I'm going to combine these right here to give me a positive 1. Bring down the 1/2 x since I haven't done anything with it in this step, and bring down the equal 11. So now I don't have any like terms that I can combine on the left anymore, and I don't have any like terms I can combine on the right. So the next step is I need to get all my variables on one side and all my constants on the other. So right now I have my variable on the left side, 1/2 x, and I have a constant 11 on the right, but I also have a constant on the left, which is positive 1. So in order to get rid of that, I need to do the opposite of adding 1, which is to subtract 1. So subtract 1 from both sides. These cancel, and I have 1/2 x equals 11 minus 1, which is 10. And now I want x to be completely by itself. I've reached my goal of having all the variables on one side and all the constants on the other, but I have not reached my goal of having x completely by itself. And so the only thing left in my way of having x by itself is that 1/2. 1/2 is being attached to x by multiplication. So I could divide both sides by 1/2. Or you could think about this as x is being divided by 2. So really the operation that's attaching x to the coefficient is division. So division by 2. To undo division, I'll just come over here and rewrite this as x over 2 equals 10. So 1/2 x equals 10 is the same as x over 2 equals 10. That way we're kind of envisioning it as division, and using inverse operations, we would multiply by 2 to get rid of that 1/2. These cancel, and I have x equals 10 times 2, which is 20. So my answer for this first one is x equals 20. Okay. So now on the second one, we have x over 5 plus 4 equals negative 10. And I want x completely by itself again. And so I'm gonna do, first I'm gonna identify what is in my way. Okay, so I don't need to distribute anything. So the two things that are in my way of having x by itself are 4 and 5. And the operation that is connecting 4 with x is addition, and the operation that's connecting 5 with x is division. So I need to do the opposite of those. But if you remember, I'm going to undo addition or subtraction first, then I'm going to undo multiplication and division second. So I need to undo addition by 4. And the opposite of adding 4 is to subtract 4. So I'm going to subtract 4 from both sides. These will cancel. And I'm left with x over 5 equals negative 10 minus 4. They're both negative, so this is going to come out to be negative 14. Okay, so now there's only one thing left in my way of having x completely by itself, and that's that 5 by division. So the opposite of dividing by 5 is to multiply by 5. These cancel, and I get x equals negative 14 times positive 5 is negative 70. So negative 70 is your answer for this question. All right. So this one's a little bit trickier because we have fractions on both sides. So we have 2x minus 4 divided by 5 equals 3x plus 3 divided by 10. So the easiest way to go about this, there's a couple ways you can go about it, but the easiest way to go about it is to do cross multiplication. So that just means that I'm going to multiply the 5 by the 3x plus 3, and I'm also going to multiply the 10 by the 2x minus 4. So what that looks like is 5 parentheses 3x plus 3 equals 10 parentheses 2x minus 4. And cross multiplication is pretty much just a shortcut of what we would have to do anyway, because we want to get this 5 out of the denominator. So in order to do that, we would have to multiply both sides by 5. Those would cancel, that one would stay. And then in order to get rid of this 10 in the denominator, we would have to multiply both sides by 10. These would cancel, the other side would stay. And so you see we have 5 being multiplied to 3x plus 3, and we have 10 being multiplied to 2x minus 4 on the other side. And so that's the reasoning for why cross multiplication works. But you can just skip that and go straight into cross multiplying. So 5 times 3x plus 3 on the left, and 10 times 2x minus 4 on the right. All right, so now that we have this, it looks more like something that we know how to solve. So the first thing I'm going to do is distribute. I got to distribute the 5 and also the 10. I'm going to do those at the same time because I feel like we're pretty comfortable distributing at this point. Okay, so 5 times 3x is going to give us 15x, plus 5 times 3 is going to give us 15. 10 times 2x is going to give us 20x, and 10 times negative 4 is going to give us minus 40. All right, and so I have 15x plus 15 on one side, 20x minus 40 on the other. Now that I've distributed, my next step is to get all the variables on one side and all the constants on the other. And so I need to move either the 15x over to the right or the 20x over to the left. And what I'm going to decide to do is move the 15, just because I like to avoid making my term with x negative if I can. So those cancel. I get 15 equals 20x minus 15x is positive 5x. Bring down that negative 40 since I haven't done anything with it yet. Okay, so now what I see a lot of you are tempted to do is subtract 15 from both sides. The reason that I'm not going to do this is because I want my x terms to be on one side, my constants to be on the other. I don't want to have my x terms and my constants on one side and have nothing on the other. So instead of doing that, I'm going to add 40 to both sides, because I need to move that away from my term that has x. Those cancel, and I have 40 plus 15, which is 55. So now 55 equals 5x. And there's one last thing in my way of having x by itself, and that is 5. And this operation right here is multiplication. Remember, if we don't see anything that is attaching it, it's assumed to be multiplication. So 5 is being multiplied to x. I want to undo that, so I'm going to use the inverse operation of multiplication, which is division. So divide both sides by 5. These cancel, and I have x equals 55 divided by 5, which we know is 11. Okay. Alright, next we have 17 plus 5 times 3x minus 7 equals 12. So my first step is always to distribute if I can. And in this case I can, because I have 5 outside the parentheses, 3x minus 7 inside, and so I'm going to distribute this 5 to both of those terms. And I get 5 times 3x is 15x. 5 times negative 7 is negative 35. Now I'm going to bring down everything that I haven't changed. So the 17 plus, and the equals 12. Make sure you don't lose any terms that you haven't changed. So now I'm going to combine like terms if I can. And in this case I can, because I have a positive 17 and a negative 35. So positive 17 minus 35 is negative 18. Bring down plus 15x equals 12. Now I want to have all of my x terms on one side and all of my constants on the other, and so I need to either move the 15x somewhere or move the negative 18 somewhere. And in order to limit the amount of steps that I use, I'm going to choose to get rid of that 18 and leave the 15x over here on the left. And so I'm going to add 18 to both sides. These cancel. 15x equals 30. And I have 15x equals 30. I know that I've got to get rid of that 15. It's currently being attached to x by multiplication. The opposite of multiplication is division. I need to divide by that coefficient 15 in order to have x by itself. These cancel. I get x equals 30 divided by 15, which I know is 2. So x equals 2. Alright, so the next one is 1/2 times 8 minus 2x equals x plus 3. I want to distribute that 1/2. My first step is always to distribute if I can. So distribute that 1/2. Half of 8 is 4. And 1/2 of -2 is -1. So 1/2 of -2x is -x. Make sure you don't lose track of that negative. I'm going to bring down everything I did not change, which is x plus 3 on the other side there. Alright, so now I want to combine like terms if I can. I see that I cannot because I have 4 minus x on one side, those are not like terms, and x plus 3 on one side, which are not like terms. I can't go ahead and combine things on opposite sides of the equal sign. So the next thing to do is move all my variables on one side and all my constants on the other. So, like I said before, I like to avoid having negatives if I can, and so I'm going to add x to both sides to get rid of this over here so that these will cancel. And I have 4 equals 2x plus 3. I did x plus x, which is 2x. And so you could have subtracted x from both sides to cancel the one on the right, but then you would have -2x. It's going to give you the same answer, but I like to avoid negatives, so that's what I did. So now I have all my x terms on one side, but I still don't have all my constants on one side, so I'm going to subtract 3 from both sides. These cancel. 4 minus 3 is 1 equals 2x. What is still in my way of having x by itself? The coefficient of 2, and that is attached by multiplication. And the opposite of multiplying by 2 is to divide by 2. And so I'm going to divide by 2 to undo that there. These cancel, which is why I did that in the first place. And I'm left with x equals 1/2. Cool. Alright, this is the last one in this section. So 3x plus 9 equals 8x minus 12. Can I distribute? No, there's nothing to distribute, so the next step would be to combine like terms if I can. I also cannot do that because 3x and 9 are not like terms, and 8x and -12 are not like terms. And so the next step would be to get all my variables on one side and all my constants on another. Again, to avoid negatives, I'm going to choose to move the 3x instead of moving the 8x, but it's entirely up to you which one you move. So in order to move that, since this is positive 3x, I undo it by subtraction. So subtract 3x from both sides, those cancel. 9 I'm bringing down since I didn't do anything with it, equals 8x minus 3x, which is 5x. Bring down the -12 since I haven't done anything with it. Okay, so now, which one am I going to move, the 9 or the -12? I'm going to move the -12 because I need to get it away from my x term. 9 is not in my way of anything, so I'm going to leave it alone. But 12 is in the way because it's attached to that x term. It's attached by subtraction, so to do the opposite of that, I would add 12 to both sides. These cancel. 9 plus 12 is 21. Bring down the 5x. And now the only thing left in my way of having x by itself is 5 by multiplication. So I want to undo multiplication by 5. The opposite of that is to divide by 5. These cancel, which is what I wanted. And I'm just going to leave it as x equals 21 over 5. Cool. So hopefully y'all are comfortable with solving multi-step equations. I would suggest, if anything that I said in this video was confusing for you, that you take some time this weekend to study solving multi-step equations, as it is the most heavily tested topic on this Unit 1 exam.